Find the total area of the regions contained by y equals f of x, and the x-axis for f of x equals x cubed plus 2x squared minus 3x. So basically we're finding the area bounded between the x-axis and this cubic function x squared, so x cubed plus 2x squared minus 3x. So hopefully the first thing you do is realise that we need a sketch of this would look really good, because we need to know where the area is positive and if it's negative anywhere where it's negative. So we need to try and factorise it and find the intersections. So before you dive into the factor theorem, do observe that you've got x as a common factor in all three of these terms. So if we pull that out, it should hopefully be a lot easier to factorise. So if we pull an x out, it's going to be x squared plus 2x minus 3. And then if we look at that x squared plus 2x minus 3, if you look at factors of 3, 3 and 1, you can make a 2 with that if they're different signs. So that equals x, x, and you've got a 3 and a 1. And it's got to be plus 3 and minus 1. So that tells us that we know this is a cubic. It's a positive cubic because the x cubed term is positive, so it's going to do something like this. And we know we have roots at x equals 0, minus 3 and 1. So if we just draw some x's, it's going to need a bit of room out to the left. Don't really need that room to the right, but never mind. So we know it goes through at 0, and so 1, 2, minus 3 can be there, and then 1, if that's minus 3, 1's probably around there. So it's a positive cubic. It's going to come up like this, it's going to turn, it's going to go through 0 and turn again, something like this. Going to go up to the moon and it's going to go down there. So this is f of x, and the x-axis is this. So what we've got then, the area enclosed, well, is this bit, and there's also this bit. So you know, if a function is f of x is positive and continuous, you know that the integral between a and b of f of x dx is going to give you the area. This is going to give you the area, right? So say that area, right? If the function is negative all the way through, then it's going to give you the answer, but it's going to be negative. So basically, remember what this integral does. If we do a definite integral, it adds up all these little rectangles. If we integrate over the whole thing, so say we were to go all the way from minus 3 to 1, well, some of these rectangles will have positive area, most of them, all these little ones in here, they'll all be positive, but then you'll get this negative area. So if we integrate the whole thing, you'd end up with something that's not right, because it would, some of this negative area would cancel out some of this positive area. So what we need is the whole bit of area. So what we need to do is split the integral. So the area, total area, is going to be the integral. So the first bit, no problem, nice and positive. So this is 0. So the integral from minus 3 to 0 of f of x dx, so x cubed plus 2x squared minus 3x with respect to x, minus the integral. Now I'm taking this away because I know that the answer to the same integral between 1 and 0, 0 and 1, is going to be, it's going to give me the area, but it's going to be a negative answer. So I'm just going to subtract it. So minus the integral from 0 to 1 of exactly the same function, x cubed plus 2x squared minus 3x dx. Probably might have a bracket in that one too. Okay, so it's not too bad because we've got these zeros in here that are going to help us. So let's start to work out the antiderivative. So the first is going to be x to the 4 over 4. x4 over 4 plus, well, it's 2x cubed over 3, 2x cubed over 3 minus 3x squared over 2. So it's that function evaluated at 0 and at minus 3. And then we're going to take away the same function, so x4 over 4 plus 2x cubed over 3 minus 3x squared over 2. I can't fit it. Same function, antiderivative function evaluated between 1 and 0, so sorry about that. I'm just going to draw on the metal. Between 1 and 0. We're going to substitute 0 into this and take away the value when we put minus 3 into this. So this first one is just going to be minus, which is 0 plus 0 minus 0, so 0 minus, and then we're going to substitute minus 3 into here, so it will be minus 3 to the 4 over 4 plus 2 minus 3 cubed over 3 minus 3 squared over 2, so all of that. And then we subtract, we're taking away all of this, and we're just going to put 1 into this, which should be a lot easier, hopefully. So, and then we're just going to take away 0, so I don't really need much of that. So it's just 1 to the 4 over 4, which is 1 over 4, plus 2 times 1 cubed over 3, well, that's just 2/3, minus 3 times 1 squared over 2 is 3 over 2. And then, like I say, I would have this and subtract 0, but seeing as I didn't write the 0 here, I'm not going to write it here either. Okay, so you end up with equals, so it's minus all of this, minus 3 to the power 4, or 3 to the power 4 is 27 times 3, which 3 cubed is 27, times by 3 again is 81, is positive, so it's 81 over 4, plus minus 3 cubes minus 27 over this 3 is minus 9, and then times by the 2 is minus 18, so minus 18. Minus, then you've got minus 3 squared is 9, times by here is 27 over 2, so minus 27 over 2. And then, so that's that bracket, and then I'm subtracting all of that. So actually, I might just say minus a quarter, minus 1 over 4, minus 2 over 3, and plus 3 over 2. So that's just distributing this minus sign into that bracket. So what you can do is put certain things together. So we have sort of minus 81 over 4, minus 1 over 4, so that must be minus 82 over 4. And then you have, if you look at the, well, I'm just going to write the 18, so minus 18 is plus 18. Then you've got minus 27 over 2, so that's 27 over 2, plus this 3 over 2, so that must be 30 over 2, so plus 30 over 2, which is 15, so that's dealt with the halves, and then what we haven't dealt with is this minus 2/3, so minus 2 over 3. So minus 82 over 4 could be written as minus 41 over 2. Then you've got plus 18 plus 15, well that's plus 33. And then you're minusing 2/3, minus 2/3. So minus 41 over 2, well 20 times 2 is 40, so this must be minus 20 and a half. Plus 33 minus 2/3. So that is minus 20 plus 33 minus a half minus 2/3. So minus 20 plus 33 is 13, so equals 13. Then you've got minus, well, I'm going to have to give these a common denominator, so it's going to be sixths. So minus a half can be minus 3 over 6, and minus 2/3 can be minus 4 over 6. So you end up with equals 13 minus 7 over 6, which is the same as 13. Well, 7 over 6 is 1 and 1/6, so minus 1 and then minus another sixth. So finally, 13 minus 1 is 12. 12 minus 1/6 is going to be 11 and 5/6 units squared. So it's quite a lot of fraction work there. It depends on what paper you get it in. Obviously, hopefully you get to use technology. It's a sort of question where through no lack of understanding you can get it wrong just because there's so much computation to do, especially if you're trying to go quickly and you're trying, there's just a lot of bookkeeping and you don't have enough space. It's tricky.